In this video, we will discuss on the decoder, another digital circuit that will do translation of the input. So decoder is a combinational logical circuit that perform a reverse encoder function. Okay, for example, we have BCD to decimal decoder. Okay, when we have decimal to BCD encoder, so we need a BCD to decimal decoder. So the ratio is 4:10. And then another example, we have BCD to 7 segment decoder. So these two are example of the decoder. So we look for the BCD to decimal decoder first. So BCD to decimal decoder will convert each BCD codes into one of 10 possible digit indication. So based on the 4 digit of binary in the BCD, it will convert to the decimal value. Okay, for example here, let's say a BCD 0011, which is referred to 3, input will activate the 3 output. So this one is the binary input, and then it will produce 3 output, as 3 is equal to 0011 in decimal. Okay, this decoder also known as 4-line, 10-line decoder, or a 1 of 10 decoder. So you need to remember the number of decoder, either BCD to decimal decoder, or it also known as 4-line, 10-line decoder. Okay, this is the logic symbol for the decoder BCD to decimal. So the input, we have A, B, C, and D, because we have 4 bits of binary. And then it will translate into decimal output, which is the possibility we have 0 until 9. So the output here is based on the input at here. Let's say A is 0, B is 0, C is 0, D is 0, so the output will be 0. Okay, example here, design a BCD to decimal decoder. So you need to construct the truth table. Your truth table must have 4 input, A, B, C, and D, and then it will generate for 10 output. Sorry, okay, 10 output from 0 until 9. So after you construct your truth table, you need to be able to identify the Boolean expression of each output. Okay, let's say ABCD is 0, so the output will be 0. Mean it activate the value of 0. Output 001, it will activate the value of 1. So basically this is the trend or the pattern of the output. So based on this output, you need to identify the Boolean expression. Okay, we have 10 column for the output, so we have 10 expression. Okay, starting from 0, so 0 here come from A naught, B naught, C naught, D naught. Okay, the SOP refer to the output equal to 1, and then identify the SOP. Okay, for here 1, so it activate in 1, so A naught, B naught, C naught, and D. Okay, until 9. For example, 9 here, we have 9 come from 1001, so we have A, B naught, C naught, and D. So this is the Boolean expression. So based on the Boolean expression, you should be able to draw the logic circuit. Okay, this one only involve the inverter as well as the AND gates. So your circuit only have inverter and AND gates, and it produce 10 output. Okay, next one is BCD to 7 segment decoder. The common output display is a 7 segment display decoder. So we have this 7 segment, 1, 2, 3, 4, 5, 6, 7. So this is the 7 segment display. Okay, when you look at your calculator, you also can identify these 7 segment in your calculator screen. It will display based on this segment. So this segment will help in order to generate the decimal number, to display the decimal number, either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay, and then the BCD to 7 segment decoder accept the BCD code on its input, and then it will provide the output to derive the 7 segment display devices in order to produce the decimal readout. So you can read the number that being displayed. Okay, either 1, 2, or 3 until 9, from 0 until 9. Okay, example here for BCD to 7 segment decoder, we have 4 input. So the input is the 4 bits of the binary A, B, C, and D, and then it will produce output either E, B, C, D, E, F, G. Okay, this one 7 segment. If the input to the decoder are 0, 0, 1, 1, okay, 0, 0, 0, 0, 1, 1, so the 7 segment display device will activate A, B, C, D, and G in order to display number 3. Okay, let's say here the output, the input is 0, 0, 1, 1. So that's mean in decimal it is equal to number 3. So in order to display number 3, it will activate this segment, this segment, this segment. So A segment, B segment, G segment, C segment, and D segment. So you can read out that at the screen display is equal to number 3. And then this is the truth table for BCD to 7 segment decoder. We have input A, B, C, and D, and then the output is A, B, C, D, E, F, G. This one 7 column of the output. Okay, if the input 0 at here, so when we translate into decimal, it's equal to 0. So in order to display the 0 number, it will activate segment A, segment B, segment C, segment D, segment E, and segment F. Okay, when we look back at this one, if we want to display number 0, so all the segments are activated except G segment. Okay, that's why under the output here we have all 1, only 0 at the G, because we want to display number 0. Okay, another example here, let's say we want to display number 4, 0, 1, 0, 0. So this one equal to 4. So it will activate number segment B, segment C, segment F, and segment G in order to display number 4 at your screen. Okay, the next part is decoder application. So a 2 variable boolean expression of y, example, the equation is y equal to EB plus EB naught plus A naught B naught. So this expression can be constructed using a 2:4 decoder and an OR gate. Okay. So based on this expression, AB plus AB naught plus A naught B naught. So based on this equation, we identify that we only have 2 input, which are A and B. Okay, so if there is 2 variable, so the most possibility is 2 power of 2 equal to 4. So AB will produce either 0, 1, 2, 3 numbers. And then you need to be able to identify what is the value here and how to construct this decoder. So it will do based on decoder 2:4, 2 input, 4 output with 1 OR gate, and then it produce this y, which is referred to the equation. Okay. The next example, a 3 variable boolean expression can be constructed using 3:8 decoder and an OR gate. So you need to know how to draw this part, the decoder combination with the OR gate. So let's say it given you y equal to AB naught plus ABC naught plus ABC. So based on the equation, you should realize that it has ABC as the input. And then based on 3 variable, so it will produce 8 output combination. So the output will be 0, 1, 2, 3, 4, 5, 6, 7 numbers. So based on that part, okay, you need to expand the equation to make sure that all the equation have A, B, C. Okay, for example, this one we have A, B naught. This one we have A, B, C naught. This one we have A, B, C. Okay, so this one there is no C. So you assume that C naught plus C equal to 1. So assume that A, B naught times 1. So 1 is come from C naught plus C, based on the rules algebra that we have learned in chapter 3. Okay, so you expand A, B naught times C naught plus C plus E, B, C naught plus E, B, C. Okay. Then when you expand your equation, you will get A, B naught, C naught plus E, B naught, C plus E, B, C naught and plus A, B, C. Then you need to identify what are the output. So based on this equation, A refer to 1, B naught, C naught refer to 0, 0. So 1, 0, 0 equal to 4. And then here we have A, B naught, C. So 1, 0, 1. So 1, 0, 1 equal to 5. Okay, this one we have 1, 1, 0. So 1, 1, 0 equal to 6. And this one we have 1, 1, 1. So 1, 1 equal to 7. So at your sum, you have 4, 5, 6, and 7. So when you want to draw your decoder with the OR gate, okay, you must have 3 input, because this one we have A, B, C. So 3 input, and then the possibility of output is 8, and then it only sum 4, 5, 6, and 7. So 4, 5, 6, and 7 at the OR gate, and then it will be equal to Y. Okay, so that's all for the decoder part.